All right, lecture 1.10. Nearing the end of chapter 1. Okay, so we're taking a look at lines. Okay, so one of the main things that lines have are a slope. So it's the way the line is tilting, either down, up, flat, vertical. So the slope of a line that passes through the points A and B, where we have A is the sub 1s and B is the sub 2s, is given in these different forms. They're all the same, they all give a slope. The first one, you could count rise over run if you were given a graph. For example, let me grab a sticky note. If you were given a graph and you started at 0, 0, and your next point went here, you could count rise over run by going up 2, positive 2, and right also 2, so positive 2. So my slope would be 2 over 2, which would then simplify to 1. That's one way that you could find the slope with rise over run. Another way would be to use the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Or you could reverse that with the sub 1s first and the sub 2s second. But please notice the sub 1s are always lined up in front of each other, and the sub 2s are always lined up. You wouldn't switch them and have a sub 1 over a sub 2. Or another way to think about it is the change in the y values divided by the change in the x values. Alright, equations of lines. There are a few different equations of lines. The generic one that works with pretty much finding any formula for a line is the point slope. Y minus y sub 1 equals our slope m times x minus x sub 1. Another good form is the slope-intercept form. The one about this that makes it a little tricky to use is that you need to have your y-intercept 0b, where m is also the slope. And then there's the equation for a vertical line, where it's x equals whatever the x value is for a point. And notice the slope for a vertical line is undefined, because a vertical line would have the steepest slope possible. And what's the largest number in the world? Well, there actually isn't a largest number. It doesn't exist. It's undefined. So the slope for a vertical line is undefined because the largest number does not exist. However, for a horizontal line, that's a horizontal line. That would be the flattest possible thing, which would be a slope of 0. Hence, m equals 0. And then the general form for the equation of a line would be your x values first plus your b values and then your constants on the side. I don't often use this form. More often than not, you're asked to answer in that form. Okay? But every now and then they might ask you to use general form, so it's a good one to know. All right, some other pieces of interesting information. So parallel lines, remember this is a parallel line, anything like that, or maybe like that. Parallel lines have the exact same slope. So if two lines are parallel, they'll have the same slope. Perpendicular lines, however, for example, those would be two perpendicular lines. They cross each other and create a 90-degree angle. So two lines that have a slope, m and m2, they're perpendicular if when you multiply their slopes together, you get -1. Or another way to check would be the slope of one equals the opposite reciprocal of the other one. So most of the times, the way we remember it is if they're perpendicular, it's the opposite reciprocal. Let's take a look at an example of that. So let's say I have one whose slope is a half. Well, what would the opposite reciprocal of a half be? Well, the opposite would be a negative, and the reciprocal of a half would be 2 over 1, or 2. All right, so let's go ahead and check that they actually are perpendicular. We're going to go ahead and use this. Let's multiply the two of them together, so m1 times m2. Does that equal -1? Well, multiplying them, the 2's cancel each other out, and we're just left with that -1. So yeah, it does work. It checks out. They are indeed perpendicular. Because when I multiply them together, I got the -1. So best way to find the slope that's perpendicular is to use the opposite reciprocal. There is an exception though. Vertical and horizontal lines are always perpendicular to each other. Okay, so if you have a vertical line, it's always going to be perpendicular to a horizontal line. So here's our first example. Find the equation of a line. Okay, whenever I hear find the equation of a line, what I like to do is write down the point-slope form. So first things first, write down point-slope form. There are exceptions to this, but pretty much this is the go-to form. So whenever I hear I'm writing the equation of a line, I'm going to write this baby down. And then I have to ask myself, what do I need to fill this out? Well, I need my slope, that guy right there, and then I need a point, x1 and y1. Okay, I need these two things and I can fill it out. Let's see what I'm given. So I want the equation of a line that passes through this point. Oh, look, I have a point. I am given a point. So here's my point, -4, 1. Awesome. And perpendicular, oh interesting, to the line passing through these 2 points. Write the equation in slope-intercept form. So they don't actually give me a slope. It's not fair. But remember, they will always give you a way to find slope. Okay, so I'm going to use this leftover piece of information to find my slope. Well, it says that my line is perpendicular to the line that passes through these 2 points. Well, what do I know about perpendicular lines? Well, if a line is perpendicular to mine, that means my slope is related to this slope. So what I'm going to do is I'm going to find the slope of the second line, and then from there, use it to find my slope. So use other lines slope. We need to find it first. So this is going to be the slope of my second line. I'll call it M2. Slope of second line. So M2, using our formula, I'm going to go ahead and use the y2 minus y1 over x2 minus x1. I'll call these my sub 1s and my sub 2s. Plugging them in, I've got 5 minus -3 all over 4 minus 1. And working that out, that's going to be 8 over, what is that, 3? 8 over 3. I'll just go ahead and leave it as 8 over 3. Okay, but this is the slope of the other line. That's not my slope. My slope is perpendicular to that slope. Well, remember, how do we decide how to find it? We use the opposite reciprocal. So, opposite reciprocal of 8 over 3 is going to be, well, the opposite would be a negative. The reciprocal would be 3 over 8. And there we go. I've found my 2 pieces of information I need to fill this out. So, plugging in my slope, -3 over 8, and plugging in my point, it's going to be 1, and that'll be -4. Let me go ahead and write this nicer on the side. Y minus 1 equals -3 over 8 times x minus -4. All right, I might be tempted to finish, but I need to check if I need to show my answer in a certain way. I need to write my answer in slope-intercept form. In that form is this one right here, where you solve for y. Okay, so I need to solve for y. At the moment, I'm not solved for y. So let's go ahead and distribute this out. Oops, that's supposed to be a negative. -3 over 8 times 4 over 1. Okay, let's go ahead and simplify that. It's going to be a 2 and a 4. Then y minus 1 equals -3 over 8x minus, multiplying this out, 3 over 2. Okay, almost done. We got to get y by itself and then add these 2 fractions. I'm going to use the building up property to add these 2 together. So I'll make that into a 2 and then that into a 2. The nice thing about 1 is you can turn it into anything. So 1 I just turned into 2 over 2. Sorry, that looks really hideous. Oop, bug. Okay. 2 over 2. Can you see that better? Slightly. Die. Okay. Alright, we were adding these fractions before that bug came and interrupted us. Okay, y equals negative 3 over 8x. Adding fractions, negative 3 over 2 plus 2 over 2. Give me negative half. And there we go, my answer is in slope-intercept form. Okay, so please notice this is something I'm going to be looking for in your work. Please remember to use your equal signs. And if you can, do your best to line your equal signs up. And if your work continues on the side, please go ahead and indicate with an arrow. A lot of you have been using an arrow in your work, which I really appreciate. Helps me to grade your work. And also helps you to keep your own work organized, so when you go back and check it, you know what you were doing. All right, let's see. Ooh, this is the last. Indeed, it's the last problem for this section. Awesome. All right, slope as a rate of change. So a computer is purchased for $1,000. After 3 years, the value of the computer is $550. Assume the rate of depreciation is linear. What does this mean? Well, this means when I write a formula for this, I'm going to assume it's linear, not quadratic or logarithmic or anything. It's the type of equation. So that means we're going to be using x to the 1 power and y to the 1 power. All right. Part A. Find an equation that represents the value v of the computer after t number of years. All right, well, what information am I given? Well, I know after 3 years, the value of the computer is $550. Okay, so that's a pair of info. So 3 years is paired with, oh no, he's back. Okay. 3 years is paired with $550. Okay, and so to write the equation of a line, remember we're looking at something linear, so I'm trying to write the equation of a line. I need a slope and a point. So right now, I have actually created one point. So the question is, do I have a slope or am I given another point? Well, this other piece of information here, it says it's purchased for $1,000. So that means when he first got it, it was $1,000. So when you first get it, has time passed? No, it's 0 years have passed, right? So here's my other piece of information. The 0 years is paired with $1,000. So I'm actually given 2 points. Well, no problem. I can use 2 points to find a slope, and then I can plug that into my equation. So for the equation, I'm going to use, let's see, I could use point-slope form, or I could use slope-intercept. And I might want to use slope-intercept because this is an intercept. My x value, or my first value, is 0. So this is my intercept, or my y-intercept, generically called y. But notice in this problem, where you need to use v and t. So t is my x values, and v, or v of x, is my y value. Okay, remember generically we use x and y. Okay, so my equation y equals mx plus b. This is point slope. Oh, slope-intercept, excuse me. We're going to use this to write our equation. Okay, so plugging this in, my intercept value, b, is going to be 1,000. Which means all I need to do is find my slope. And to find our slope, remember, we can use our formula. M equals my x1 value minus my my y1 minus y2, all over x1 minus x2. So I'll go ahead and label these as my sub 2's. Oops, x, y. And let's subtract them. So 52. Oh, I could have done it the other way. Might have been easier. Okay. And plugging that on into my calculator. Let's see. 550 minus 1000. I could have done that in my head, but I didn't. Okay, and then 3. And that simplifies to, ooh, I don't have quite enough room. 150. Ooh, I don't like writing it that way. M equals 150. Okay, so my slope is 150. Plug that in. And that's a negative 150, sorry. Remember that minus sign. Okay, so you might be tempted to say we're done, but remember, I was using the generic x and y variables. That's not what we're being asked to use. My x variable is the time, which we said was going to be t. So I'm going to replace x with t. And I'm going to use v as my y. So v of x would be my, v of t. Remember, we're using t. There I go, and make it all messy. V of t. There we go. All right, and there we go. We have an equation in terms of t for the number of years. All right, so it's asking me, what does the slope represent? Well, what is my slope? My slope is negative 150. And I'll go ahead and just write that over 1 for the sake of this. So remember, the top of our equation is the y values, excuse me. So the y values are the dollars. So the dollars. And my x values, or my t values, were the number of years. So this is saying, my slope is saying, that the amount of money am I losing money or earning it? Ooh, losing. It's depreciating, so the minus sign. So my computer's value goes down $150 every, how many years? 1 year. So the computer value goes down. We know it goes down because of the negative. $150 every year. You could say every 1 year, every year, period. Okay, so that's how you'd read the slope. Remember to check what the y values represented. In this case, it was dollars. And check what the x values represented. In this case, it was number of years. All right, last part. How many years will it take for the value to be 0? Well, what is the value? The value was v of x, right? So I want to know when my value, or v of t, sorry, is 0. Well, how will I do that? Well, lucky for us, we created an equation with v of t in it. So here's my equation, v of t. And I want to know when this is 0. So I'm going to go ahead and take out v of t and substitute in 0. And I have created a linear equation to solve. So I can solve for the time that it'll take for the value to be 0. Let's go ahead solving. So minus 1,000